So when we say what is the molar solubility of, what we're asking is solve for X. The long and short of it, that's what we're asking for. What we're really asking is how much of each ion dissolves up in water if you saturate the solution. Remember, this is kind of that weird thing where we kind of told you guys, oh, it's completely insoluble, none of it dissolves, but then it turns out a little bit of it dissolves. It's that thing. We're trying to figure out basically how much of this salt dissolves. So let me show you. There's another little trick too with the units at the end, typically. So first thing is, notice that there is a KSP chart. There's a link on this to the KSP, so you can always get to it. Remember that KSP is at 25, and remember that's kind of a to-do because we could, if we just say determine the KSP at an unspecified temperature, don't just like look up on the chart and try to find it, because we're going to be giving you numbers that won't give you the numbers from the chart. But this is the chart you're going to use to solve for the molar solubility. So this is in order again by element. Let me find silver. There we go, silver. AgCl has a value of 1.6 times 10 to the minus 10th. So on this one, the KSP is equal to 1.6 times 10 to the minus 10th. So for the molar solubility, I'm just going to write my ice chart out. So AgCl solid. And this is about it dissolving. So KSP, we're just trying to figure out how much has dissolved. So each ion is dissolving. ICE, and notice this is a solid. I don't even put it in. I don't have any of either of these until I start dissolving them. And then I'm going to have some amount X, X, X. So when I write my KSP expression, KSP, and I should have done this before I wrote my ice chart. Cl minus. That's my KSP expression right there. So KSP is equal to, this is going to be X times X. So I'm going to write it as X squared. I already know the value, 1.6 times 10 to the minus 10th. You should use that chart that is in this lesson because that's what all of the numbers are tied to in the homework and the quizzes. On tests, you will be given the value that you need. So I'm going to take the square root of both sides, and then that will give me my X. So I've got 1.6 e to the minus 10th. Oops. 1.6 e to the minus 10th. And then I'm just going to do square root of answer. So that tells me that my X value is 1.3 times 10 to the minus 10th. Now hang on. We're not always done because often it will then add in grams per liter. So right now, my X is telling me my Ag or my Cl. So you might be like, but I thought I was looking for the salt. You are. Notice that Ag, if I have 1.3 times 10 to the minus 5th moles of Ag in a liter, Ag plus, I can say that in 1 AgCl, because there's a subscript of 1, there's 1 mole of Ag plus. So those ones all match up. If I need to figure out this number in grams per liter, it's not that horrible. I'm just going to go like that, and I'm going to do grams of AgCl. And you are most of the time given the molar mass of AgCl. I'm going to type in molar mass AgCl because we kind of figure that you already know how to do this. So it's 143.32. 143.32 in 1 mole. So I'm going to just take that number that's already in my calculator right there, and I'm going to multiply it by 143.32. That tells me, again, how many grams of my salt. So it's 1.8 times 10 to the 3 grams per liter is what will dissolve. Every once in a while it'll be like grams per milliliter, but most of the time it's grams per liter. Just pay attention to what it asks for. If it had wanted grams per milliliter, I would then do, since I've got a liter here, I would say in 1 liter there's 1,000 milliliters. Or depending, if you learned your metrics in a different way, you might have learned this. 1 times 10 to the minus third liters is 1 milliliter. Those are the same things because there's a negative up there. Those are the same things. And that's how I would get this number into my milliliters. It's just going to make it an even, like a different kind of a number. So either way, you might be given and requested for either one. Just pay attention to what it asks for the units. And that's how you solve a molar solubility problem.